So, vertical angles. Congruent angles, complementary angles, and supplementary angles. You want to make sure you learn these well because these things come up over and over and over again as we move through geometry. Okay, vertical angles probably come up the most frequently. And what happens when you have vertical angles, where'd my pen go? Is if you get two lines and they intersect. Okay. And they don't have to be lines, it can be line segments or rays, but as long as they crisscross and they make an X, that's when you get vertical angles. They share a vertex. This is one set of vertical angles. This would be the other set of vertical angles. So you end up with two sets. So vertical angles here, vertical angles here. Other times that you get them is if you have like two triangles attached or something like that. You get a set of vertical angles. Just basically anytime two lines form an X, you'll get vertical angles. Okay. Congruent angles are two angles that have the same measure. So for example, 90-degree angles, right angles. Every right angle is congruent. And it doesn't matter if I draw it itty-bitty like that or if I draw it giant like that. The angle measure is the same, so they're congruent. Okay. Now, complementary and supplementary angles, a pair of angles that add up to 90. So I could have a 30-degree angle and a 60-degree angle. And I didn't draw those to scale, obviously, but if I add them together, they're going to equal 90. So 30 plus 60 equals 90. And that can be any two. I could have a 1-degree angle and an 89-degree angle. They'll still be complementary. A good way to remember this is if somebody complements you, it means they're right. That's, try to keep that to make it so you can remember that association in your head. So if somebody compliments you, they're right. Complement, 90 degrees. Okay. Supplementary angles add up to 180. So I could have a 60 and a 120. Or any other combination of the two. Unfortunately, I never thought of a cute thing to help remember that, but if you can remember, complementary is 90, the other one's 180. Now, with complementary and supplementary, the angles could be touching each other. So angle 1 and angle 2 make a 90-degree angle, or they could just be floating off in space. Same thing with supplementary. They could be touching each other, and they'll make 180 degrees, or they can just be randomly wherever. Okay, so the only rule is that they have to add up to 90 or add up to 180. Okay, so adjacent angles. Think about if you live in an apartment or a duplex and you guys share a wall with your neighbor, as annoying as that is. That's what adjacent angles do. They share a wall. So when you talk about adjacent angles, I can have two angles and they share this common ray and a common vertex. This is the part that they share. So they're touching each other. So vertical angles are across from each other, adjacent angles are touching each other. When you have supplementary adjacent angles, they make what's called a linear pair. And this can be from two intersecting lines or a ray in a line or even a segment in a line. But a linear pair are two angles that share a side and are supplementary. So the measure of angle 1 and the measure of angle 2 will equal 180 degrees. That's something I need to tell you about. When we talk about angles, we use the symbol for an angle, and we can put the number or the letters. This is the actual angle. When we want to talk about the number of the angle, like the degrees of the angle, you put a little m in front of it. And this is the measure of the angle. Okay, so that's how you know when you're talking about the actual physical angle itself versus how many degrees the angle is. And then on segments, which we had done earlier, if I'm talking about the segment, this is the actual segment. And if I don't put the bar over it, that's the length. Just so you know when you see these things what they mean. So with a linear pair, you're going to have adjacent angles, so they're going to be touching, and then they're going to add up to 180. An angle bisector is a ray or a line, or maybe even a segment that divides the angle into two congruent angles. So basically, a bisect means to cut in half. That's what the word bisect means. So if we have an angle, just our normal everyday angle, this thing comes in and it cuts it into two pieces where angle 1 will equal angle 2. That makes this the angle bisector. So sort of like a midpoint cuts a line segment in half, an angle bisector cuts an angle in half. And basically anything that cuts anything in half is a bisector. Now we're going to get into some postulates and theorems, and these are postulates and theorems that we all actually kind of use more often. The other ones were sort of just kind of definitional, but these are ones that are actually going to get used. We have the angle addition postulate, which is similar to the segment addition. Angle addition and segment addition are similar. Basically, if you have some point D that's inside ABC, so if I draw this angle ABC, and I have this point D that's just sort of floating out there, but it's inside the angle. And I draw a line, just make it dotted, which creates two new angles. Then angle ABD, which I can call angle 1 if I want, and angle DBC, which I can call angle 2, will add up together to make the whole thing. Now, naming angles is important that we keep that vertex in the center. During the course of this, class, as long as you can recognize the names of the angles as what they are, if working with all those letters can be too confusing, you can label the angles with numbers, and I can say the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle ABC, if that's easier to keep track of because it's less to look at. You can do that. Just make sure you label the picture so I know what you're talking about. Okay? And even if you wanted to, you could say like this whole thing was angle 3. And so you could say the measure of angle 1 and the measure of angle 2 is equal to angle 3. Just make sure you label it. Okay? The angle bisector postulate says an angle has exactly one bisector. So if I come in and I draw an angle and I want to cut it in half, well, there's only one way you can cut something in half and it be even, right? It's like when, did anybody have siblings and you guys argued over who got the biggest piece when things were being shared? Yeah, okay, so, right, if it wasn't cut perfectly in half, it wasn't fair, right? There's only one way to cut it perfectly so that everybody got the equal amount. Well, that's the same thing with the bisector. There's only one way we can cut that and have angle 1 and angle 2 be equal. So there's only going to be one bisector. Linear pair postulate, two angles that form a linear pair are supplementary. This is one of those sort of more definitional things. And linear pair and supplementary get interchanged a lot because they're both 180 degrees. With the linear pair, the difference between a linear pair and just plain supplementary is these angles are touching. With supplementary angles, they don't have to be. So if you have two angles that are not touching, you can't call them a linear pair. If they are touching, you can call them either a linear pair or you can call them supplementary. Okay? So just make sure, and again, that means they're 180 degrees. And the picture for that is like this, and we could draw it this way this time. Just make sure that the angles are attached, like attached at the hip. You know? Okay, now we're going to get our first two theorems. And the difference between a theorem and a postulate is that a theorem has had to be proven. We don't just accept them as true. So we either have to prove them or somebody else has had to prove them. And we have two of those. We have the sum of the measures of the angles of a linear pair is 180. And this is a proof that is, or this has been proved by definition. So if I have that linear pair that I just drew, I have the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. Vertical angle theorem is that if two angles are vertical angles, then they are congruent. So when I draw this, and I get these four angles, remember angles 2 and 4 are a vertical pair, and 1 and 3 are a vertical pair, so the measure of angle 1 is equal to the measure of angle 3, or you could say angle 1 is congruent to angle 3. The measures are equal, the angles are congruent. And then I have the measures of angle 2 is equal to the measure of angle 4, or I can say angle 2 is congruent to angle 4. The way this was proven, okay, if angle 1 and angle 2 add up to 180 degrees, because they make a linear pair, right? They make a straight line. And angle 1 and angle 4 add up to 180 degrees because they make a straight line. Well, angle 1 is the same of itself in both of those, right? So that means 2 and 4 have to equal each other. Does that make sense at all? That's how they proved that, was they took that 180 degrees and then the other 180 degrees, and they said, well, this part's the same, so these parts have to be the same. So that's how that works. Don't worry, I'm not making you prove this. I'm just telling you how it was proven. Okay, so finding the complement or supplement involves subtracting. If it's a complement, 90 minus. If it's a supplement, 180 minus. Okay. Finding the complement and the supplement of 35. To find the complement, I'll do 90 minus 35. To find the supplement, I'll do 180 minus 35. 55. 145. Any questions on that part? Okay. Sometimes we have compound statements. Okay, find the complement of the supplement. When that happens, you find this first. So you find the supplement first, then you find the complement of whatever number that is. So then you find the complement of this number. So the supplement of 123 would be 180 minus 123, which would be 57 degrees. And then I find the complement of that. So I do 90 minus 57, which would be 33 degrees. I think. Is that 33? Did I do that in my head right? We have intersecting lines, and the intersecting lines form vertical angles. Okay, so I have this set of vertical angles and this set of vertical angles. Now I know that vertical angles are equal, so these two are going to be equal. So that tells me that y is going to be 123. But I don't know what either of these are. They didn't tell me that, so I have to find that. Well, I was going to say, I do know that these two or these two add up to 180. Or, these two or those two. Depends on how you want to go around it. But basically, you have two sets of vertical angles, and one of each add up to 180 because they make straight lines. So to find x, I take 180 and I subtract the 123 from it, and I get 57. We could, if we needed to, find every missing angle. But before we go through that, are there any questions on any of the ones that we're actually supposed to find? Yeah. See? X or Y? Okay, well X, see this symbol here? That means that these two together equal 90 degrees. So I did the 90 minus 43 to get the 47. Okay. And then the Y and the 43 make a straight line. So that means it's 180. So to find y, we did 180 minus 43. That gives you 137. And well, I'd use the same concepts pretty much to get the other two angles. These two angles are vertical because of the straight lines. So that would mean that this one was 43. And then these two angles make a straight line, which means they add up to 180. If this part's 90, what does this part have to be? So 180 minus 90, 90. So we could find that if we needed to. Same over here, 27. These are vertical, so this would also be 27. These two are vertical, so this would also be 54. Right, see my straight lines? What I don't have is a straight line happening here, like a vertical angle thing happening, because this line doesn't come through. But this part's 90, which means this part's 90. And so I could do 90 minus 27, and I could find this. 90 minus 20 is 70, minus 7 is 63. So you could find all of them if you needed to. I'm not going to give you any problems where you have to find every single angle. I'm just saying if you did need to, you would use the same ideas and just kind of move around it to find them. Does that make sense? Okay, so a conditional statement. These get used in philosophy, logic, critical thinking, and math. A conditional statement is called a conditional statement because there's a condition. And that's the if part. So it's an if-then statement. If blah, then blah. There's a cause and effect relation. The cause is the condition, and the effect is the result, obviously. And it's usually if P being any sentence, then Q being a different sentence. So for my example, it says, if you do all of the homework problems, then you will get a 100%. The P would be the you do all the homework problems, and then the Q would be the you will get a 100%. Now, in the conditional statements, the hypothesis is unproven. It's an unproven theory. It's a supposition. Suppose you do all of the homework problems. Or it's an unproven theory because I'm theorizing that you'll do all of the homework problems, but I haven't. Maybe you won't, right? So it could happen or it could not happen. It's if. So that's the hypothesis, the first part, the if part. You do all of the homework problems. Now, for a conditional statement to be true, you do that first part, or that if part happens, then the conclusion has to happen. So if you do all of the homework problems, then the conclusion is you will get 100%. So if you don't do the problems and you don't get 100%, it's still a true statement. If you do the problems and then you get 100%, it's a true statement. When it becomes false is when there's a counterexample. You do all of the problems and somehow that 100% doesn't happen. And if there's any situation that could arise where that would occur, any at all, it'll show the statement to be false, and that's the counterexample. The counterexample I could come up with, this one is the teacher grades for right or wrong. Okay. So now in this class, if you do the homework, I'm grading on completeness, right? So as long as the homework is complete, you'll get all of the points. You'll get that 100%. But in a different class, maybe that's not the case. Maybe you could do all the homework and you'd still not get the 100% because they'd be grading the actually grading the problems to see if they're right or wrong. That would be a counterexample, which would make that first statement false. Does that make sense? Other things, if you clean your room, then you'll get your allowance. Well, let's say you cleaned your room and then you didn't get your allowance because, I don't know, maybe your parents didn't have any money that week. That would be a counterexample. You know, just anything at all that shows that it's not true, and it can be any counterexample. There's not a right counterexample versus a wrong counterexample. In some cases, there can be a million counterexamples. You just have to pick one. Okay? Any questions on that? Okay. Oh, my typo. We have to fix that real quick. I typed the same word twice. It's not the same word. It's contrapositive. So we had the conditional statement. The converse is when you flip. And the best way I can think of to remember this is, you know the Converse tennis shoes, and how when you look at the shoe, the star is on the inside of your ankle in the high tops? You guys know what I'm talking about? Converse high tops? Okay, Converse high tops, look at them next time they have them at like Target and stuff. Next time you see a pair, the star, the Converse star, is actually on the inside of your ankle. And you would think that it should be on the outside where it can be seen, but it's flipped. Sort of like the Converse in math is flipped. So That might help you remember. So you take the first part and the second part and you switch them. So if you get 100%, then you did all of the homework problems. Okay? Now, if both the conditional statement is true and the converse is true, they both have to be true. You can get what's called a biconditional, which means that it can go either way. And that's an if and only if statement. Now the IFF with two F's, ifs with two F's basically, in math is a symbol or shortcut for writing if and only if. So if you see IFF, you read it as if and only if. So here we would read this, you will get a 100% if and only if you do all of the homework problems. And that's the other things like if you forget your umbrella, you will get wet if it rains. You will get wet if it rains if you forget your umbrella. You could say, you'll get wet if it rains if and only if you forget your umbrella, kind of thing. Like, you know, that anything that both ways are true, you could write it as one and get if or only if. Okay, so the converse flips, yeah. Contrapositive, yeah. So the converse flips, the inverse negates. So you take, it's in the same order, but instead of being if this, then this, it's not and not. So if you do not do your homework, then you will not get 100. So you just make it no's. Just no, no. And then with the contrapositive, big long word does both. Flips and negates. If you do not get 100, see how we're flipped if you get 100? So we're flipped if you do not get 100, but we're also through the not in there. Then you did not do all of the problems. So conditional, if then, converse, flip those. Negate, put no's in there, and then contrapositive flips and puts no's in there. And we will stop there today.